Today, from killing a production Kubernetes cluster right into a process orchestration startup, this is Confluent Developer.
A very loud group of people who think Rust is the answer to everything, including cancer. And that's not the only hard part. The hard part is there's other systems outside that you don't control that have their own database. Like there's other ways to do it. Is that the best way to do it? Not really, right? But that's not really a business thing. That's literally like it's checking the validity of a token.
Hey there, everybody. I'm Tim Berglund, and welcome to Confluent Developer, the podcast where we explore the fascinating journeys of software developers tackling complex problems. In this episode, I'm interviewing Colt McNealy, the founder and CEO of Littlehorse, a Kafka-based platform to, and I quote, create, compose, and introspect your microservices, workflows, and AI agents. We talk about the rude surprise going from debugging undergraduate operating systems projects in GDB and VS Code, which is like X-ray vision, to the ordinary world of enterprise distributed systems, where you can't see anything, and what Colt wants to do about that gap. Let's listen in. Hey, Colt, welcome to the show.
Thanks for having me, Tim. It's kind of an honor.
Oh, awesome. Good to see you again. And hey, tell us a little bit about you. Who are you? What do you do?
So if you've been hanging around the Confluent Slack and the Kafka Streams channel, I'm the supplier of about 50% of the questions. So that's one thing I do. But
it's good work if you can get it.
What was that?
It's good work if you can get it.
Oh, yeah. So that's one thing I do. But what I actually do is I'm the founder and CEO of a startup called Littlehorse Enterprises, and we are in the distributed application management space. So we make it easier to build applications, workflows, integrations, AI agents in the modern world, which is distributed, sometimes in the cloud, sometimes hybrid cloud, sometimes on-premise, and with complicated business processes. So we build basically data infrastructure software.
There you go. Is it appropriate for me to think of that as a durable execution engine?
Durable execution is a smaller part of it.
Okay.
In a way. So we do workflow, and workflow and durable execution are very intimately related, but they're not exactly the same. So I don't know how much time we have to go into that, but happy to if you want.
Maybe I suspect we're going to get into it in a minute. So
okay.
Before we get there, tell us, what was the first job you ever had?
Well, it's not as cool as my dad's first job. My dad was, I think he parked cars and swept floors for $1.75 an hour. Unfortunately,
Nice.
My first job was in tech, so I can't say anything cool like that. I was my first summer of college, I got a job as a software engineer at a real estate company, and then I ended up working during school for my last 2 years of school. I got out in 3 years, but I was working during school, and then in that job, it motivated me to create Littlehorse. So this is basically my second job.
I love it. I also had a job working, writing software in college, and that's a great way to do it. You learn a lot more writing code than you will learn in
Textbooks.
Software classes.
Yes.
In whatever major it is. So.
Or I don't know if you can see back there, but the O'Reilly books are great too.
Yeah, they're not bad at all. There's some good ones.
Yes.
Awesome. All right. Oh man, it's got to be a separate podcast. I'd love to talk some more about that, but we'll do that. We'll do that some other time. What is you've said you're kind of new at this, but tell us about the most interesting problem you've ever solved or are working on solving.
So I think working on solving is a better way of doing it, because it was a very humbling experience realizing how tricky everything about starting a business is. Including the technical difficulties of it, the people part of it, the business part of it, trying to translate the cool technology into actual business value is another challenge. But if we're going to focus on the technical challenge I'm solving, when I was in school, we were doing code in C, C++. I did a lot of operating system stuff. It was great because you could just use GDB, and you could stop your program in the middle of its execution and inspect where everything is. You could see all of the code that's running in a single VS Code window, and everything ran on your laptop in one environment, and distributed meant multiple cores, and you had like a cache coherence problem, but you could still see
like
all
Superman with X-ray vision. You can see
Exactly,
everything.
yes.
Yeah, it's amazing.
And then here I am. I think I'm bulletproof. I jump into the real world and I get a job, and I'm doing something. What I was working on was making a widget in a portal that allows scheduling open houses, showings, home inspections, and I think there's another thing. It was like 4 or 5 different things we were scheduling for that real estate company. And there's a lot of different parties involved and a lot of external systems. There are some real estate specific systems. There's Salesforce. There's our own internal APIs, our mobile app for our agents, mobile app for the customers. Some really legacy stuff we had in our website, and you had to coordinate all of those pieces together. And I hadn't seen the code for about 90% of what I was calling. It was just a bunch of API calls over the internet, flaky connections. Interns like me would deploy things, and microservices would be buggy, so then you'd get 500s for 3 hours at a time.
You know how those interns are.
Yeah, I took down the site a couple of times. I'll tell you about that later.
Yeah, that's good to already have that under your belt. I mean, that's important experience.
I thought I was pointed once at localhost, or my local Kubernetes cluster, and I deleted every single deployment on prod.
Yep. I dropped a production database once, so it's okay. That's
not good. That's I at least only killed stateless services.
There you go. I destroyed state. I mean, I was able to restore it. It ended okay, but it's good to know the sort of primal panic when you realize the error.
I think I got our QA database hacked with SQL injection, but that's another thing. I haven't confessed that publicly yet.
Okay, that'll be the podcast series on what's the worst security vulnerability you've enabled.
Oh gosh, yeah. I mean,
it comes with. We offer legal counsel to come with you to tell you what questions to answer and what questions not to. That'll be a separate series.
I would not trust someone who looks you in the eye and says, "I have never caused a security vulnerability," because that means they haven't learned anything.
That's right. They just don't know, right?
Yes. So, back to the story.
So you're this intern, and you're being an intern. You're building code, you're learning, occasionally making mistakes, but you're seeing the comparative sort of deity-like view of the world that GDB and VS Code gives you compared to
exactly, yes,
these containers. Yeah.
Well, there's containers, and that's not the only hard part. The hard part is there's other systems outside that you don't control that have their own database. Like Salesforce has its own databases, and I can't run a transaction in a Salesforce database that also, touches our, mobile apps backing database and our agent portal backing database and that microservice, and also .loop and also SAP, right?
Yeah.
So orchestrating transactions across all those things, I just really wanted a place where I could write code on one screen that involves steps running in all of these different things with rollbacks. And that was the genesis of something that was very similar to durable execution. And I looked at some durable execution players. I won't name them, not to turn this into a hit piece. Kind of hard to use. And also the thing I realized was, this is also workflow. And workflow has predefined sets of steps, and there's an orchestrator that dispatches work to task workers that do those things. And if the workflow engine knows what's happening and what's going to happen, you can get really, really rich data out of it, and you can get better sort of control and visibility into the process. It's not necessarily as dynamic, but we do have durable execution within a task. So durable execution is basically, let's cache side effects, and if there's a retry, we don't redo the side effect, we just take the result of it. That's durable execution. So it's basically retries with caching. Workflow is predefined set of steps, go through them, and there's branching, loops, exception handling, multiple threads and such. So workflow can be Turing complete, and in fact Little Horse is. But it's very different from durable execution, and we have durable execution within Little Horse at the task level. But anyways, that is where Little Horse was motivated. It's this problem, and there's so many other things that have come with it, which is, the Little Horse was based on Kafka. It's actually Kafka is the commit log, and Kafka Streams is kind of the data store that we use. And there's many reasons why we did that. I did a talk on about that at Current 2024. If you're interested, I don't have time.
We will put a link to that in the show notes. The audience will absolutely be interested in that talk.
Yes, and if you haven't ever seen Kafka Streams, don't know what Kafka Streams is, that's actually a really great talk because I spent the first probably 70% of the talk talking about Kafka Streams.
Oh, nice. Okay.
Yeah.
And let me just say, because this isn't necessarily a show for data streaming people, so if you don't know what Kafka is, check that out. It's this durable log. You probably know what Kafka is if you're listening to this. If you don't know what Kafka Streams is, it's a Java API that's a part of the open source project that lets you do stream processing on top of Kafka topics. All the usual kinds of stuff that gets difficult that you want to do with consuming messages from a log, you do with Kafka Streams, right? So,
at the risk of getting toasted on Twitter, Kafka Streams helps you turn Kafka into a database.
Nice.
Well, it makes it possible to. That's not what most people use it for. Most people use it for, well, I have a bunch of data in Kafka, I have a bunch of events happening, and I want to quickly derive some insights that involve joining a couple streams together, counting things over time windows, aggregating things.
And putting them into a key value store, which you might also refer to as a database. It's uncontroversial. Who could toast you for that? Of course, somebody will. But
there is a sentiment. Maybe I spend too much time on Twitter. When my code's compiling, I have to scroll. And when I scroll Twitter, I feel like there's a very loud group of people who think Rust is the answer to everything, including cancer. And there's another really loud group of people who think AI agents are already smarter than us and we don't need programmers. And then there's another group that says we need Postgres and no Kafka. And Postgres can do everything that Kafka can do.
We're not going to link to that in the show notes, but I will say it is early November 3rd, 2025, as we're recording this. Very timely reference, Mr. McNealy. That Postgres instead of everything.
You can build a queue on Postgres for small scale, but there's a difference between a queue and a log. And in fact, many of the use cases for Kafka are not queues, but rather logs. I think Gunnar Morling and Jack Van Lightly both wrote fantastic pieces on this recently, I think in their own personal blogs.
Yes. We will try to get links to those in the show notes. Gunnar and Jack you need to read them.
I read Jack Van Lightly religiously. He's fantastic. But anyways, so we were talking about Little Horse being built with Kafka as the commit log. And the core scheduler of Little Horse is a Kafka Streams app. And we don't send tasks on a Kafka topic, actually. There's a gRPC API, and all the Little Horse clients interact with the gRPC API. Kafka's hidden as of a year ago, hidden from the customers or the users of Little Horse. But because it's a Kafka Streams app, every time something interesting happens, we can very easily throw it into Kafka. So then we started throwing stuff into Kafka as things happen. So we throw a stream of updates to workflows, tasks, nodes, and such, very low-level very low-level technical things happening. Like this workflow reaches this next step, or this variable was changed. Its value, the variable order status changed from shipping to delivered in this particular workflow. So now we have that data in Kafka, right? Imagine what you can do with that. So that might give you some insight into what we've been working on the last 2 or 3 months and is going to be coming out pretty soon. And the other thing that we've been doing with regards to the Kafka ecosystem is, workflows are great at responding to things happening. So you'll have a bunch of events in Kafka, and you're not going to run a workflow for a million events a second, but you could derive anomalies from that using Flink, KSQL, Kafka Streams, even to be vendor neutral here, you could even do something like, ClickHouse, and enrich things and detect anomalies, and then throw something into a Kafka topic that then triggers a workflow to handle it. So for example, fraud detection, right? One of our more common use cases is, there's some cybersecurity violation or some anomaly, some SLA is missed, something like that. We create an enriched event and then react to that in a workflow with Little Horse. So we have a two-way connectivity between the event platform, Kafka, and Little Horse. Events trigger workflows, workflows produce events.
Can I clarify there? So there's two kinds of events. I'm going to divide the world into two kinds of events, okay? One is the business events that my application creates. Somebody buys something, payment clears, thing ships, that kind of stuff. Microservice emits event to, record completed work. The other kind of event is the workflow engine or durable execution engine has made progress somewhere.
Correct.
Are you talking about anomaly detection on that second category of events?
Well, you're correct that those are two places that events can come from. But I wouldn't necessarily say they're different types of events, right?
Okay, that kind of answers my question. You're viewing this as there's a world and things
I
are
think
happening.
there's low-level events and there's high-level events. Like a click is not really that high level of an event, right? People throw they throw logs and OTel traces into Kafka. And that's a very low level event, right? But you can process that, detect that there's a lot of errors, and then you throw, oh shoot, there's some outage of some sort. Let me page the engineering team. That's a higher level event. And Confluent very eloquently points out that Kafka doesn't really care between high level and low level events. You need a data streaming platform to give you that difference. You need stream governance and you need to understand the schemas of these things, and you need a way of differentiating them, right? But they're still just events. Big events, little events, big E, little e, doesn't really matter. And the idea is that the workflow engine can react to events. We have Kafka connectors, actually just got certified on Confluent Hub, which is really exciting.
Congratulations.
That read from Kafka and trigger workflows in Little Horse, and then Little Horse produces more events back into Kafka. And that's all open source. The connector's open source, the workflow engine open source. What we're working on in our enterprise product, because I gotta make money, is a thing that will take the little events coming out of the server and the workflow engine and turn them into big events that are business meaningful.
Okay. I've got some more questions about the about both the workflow engine and the durable execution stuff that I'd like to dig into. I don't want to rabbit trail you yet. Was there more? Am I cutting you off? You want to go forward on some more of that stuff, or shall I just dive in?
I think I think we can go forward.
Now, a quick word from our sponsor. Confluent Developer, the podcast, is brought to you by Confluent Developer, the website, which has everything you need as a developer of data streaming systems. And it's completely free. We've got curriculum, hands-on exercises, executable tutorials, the online data streaming engineer certification, also free, a way to find a meetup near you, those are free. Everything is there. I really want you to be successful in your journey as a data streaming engineer, and this is the site that has what you need. Check it out at developer.confluent.io. That's developer.confluent.io. Now, back to the show. There are some things to solving a problem like this that are thorny. Now, the durable execution side of things, that's just, depending on the granularity that you go for, it's either, kind of a not too hard of a problem or a moderately technically difficult problem. So it's just kind of hard to do. The workflow engine it's software. It's all hard. There's lots of corner cases, and none of this is easy. But you also have a problem of how to express the workflow, because to some degree, writing business software in language, whatever, it's Rust if you believe Twitter, that corner of Twitter, or for most business software, it's Java. And I'm fine with that. That's my own background. But that's a workflow. You're describing a workflow. You're just doing it in a programming language. So how did you figure out, where do you fit in that curriculum or continuum? Before 20 years ago, there was, probably 25 years ago now, a flavor of XML that you could use to describe business workflows, and it was just as bad as that sounds. So, what do you do? How does Little Horse describe workflows? How did you think about solving that problem? How do you interact with your users and community and everything? Just talk to me about that.
Well, users and communities, and what's our DevRel posture and such?
I mean, well, no, however it is you interact with customers and users around that language.
I think
that solution.
This gets quite philosophical, actually, and we have a lot of discussions inside Little Horse itself about it. And then, what we what we thought, our customers actually told us something a little bit different, which was at first we thought that the workflow language we built, it is Turing complete. It's got variables, it's got conditionals, loops, it's got exception handlers, error handlers, interrupts, child threads, all of those things that you would expect in a programming language we have. So we thought, oh, people would use it like a programming language. But it turns out most of our users they do something with Little Horse that you can't do with durable execution. What they do is they write code that mirrors a business process, kind of business as code, not infrastructure as code, business as code. And then they get a good, there's better alignment between the engineering teams and the product teams with, business as code. And certain things that, certain things that are pretty technical and kind of, like if-then logic that is not really mirrored at the business level was kind of creeping in there. And people were like, yeah, it's a little messy, but overall you can kind of see the business process in this, what we call a workflow spec, this Java DSL. But there's a little bit of, that looks like data massaging. So what we've done and what we're working on with some of our users is we developed what we call checkpointed tasks, which are literally just durable execution. So it's basically what temporal does. And that is available inside a task in Little Horse. So now what we're doing is we're recommending that we take, the workflow spec, the WS spec represents a business process, and the technical details are done by the tasks, which is pretty nice because now you have what I was complaining about not having when I was an intern, which is a picture of what's happening and where in the business process at a higher level.
And the tasks are always code. I have to write those in a JVM language.
Java, Python, Go, C# support. JavaScript, okay. If we get, every time I open Twitter, I think we need JavaScript, but you don't see many people writing enterprise backends in JavaScript in the wild.
It will be a minority player in that pie chart.
Yeah. So the workflows can be expressed in code. We're also working on a visual workflow builder because we have a language that it's like workflow.execute this, workflow.declare variable, and then you have variables that you can pass into tasks. You can take the output of one task, pass it into the other. So it's very similar to writing code with a durable execution framework. And it's almost exactly the same writing the workflow. But under the hood, the thing that is different architecturally from durable execution is that compiles down to a directed graph. It's not acyclic, it's just a directed graph, which is just nodes and edges. Boxes.
Yeah, fair enough. If it's Turing complete, it's not acyclic.
Correct. I like the live fact check. But because it is a graph, right? And these are, now with this whole durable execution inside the tasks itself, what we can do is, well, it's a high enough level thing that it might actually make sense to just create a lightweight UI that lets you build workflows without writing code and see if it's usable, right? Or see if people like it. Our current users are very, generally we've got some people who have migrated off of Camunda because they went we started out server-side public license and then went to fully open source AGPL and they kind of went the other way. And we're catching some of that. And then, some people frustrated with MuleSoft. So they are used to clicking and dragging, but they actually really like the SDK, which was surprising because they're moving off of the click and drag thing. But, we might as well just try and see who uses it because we can.
Yeah. You said at one point this becomes philosophical. Could you expand on that a little bit? I'm intrigued by that statement, and I wonder if you mean what I think you mean.
Okay, so it becomes philosophical. You're roughly asking what is the do we write workflows in XML? Do we write workflows in code? What I was saying is the philosophical discussion is where is the delineation between what's a task, what's one workflow, and what's the interaction between multiple workflows together, or workflow specification to be very precise in Little Horse term. What's a task run, what's a workflow run or workflow spec, and what are multiple workflow runs composed together? That is a philosophical discussion. So you can, and we have seen live in one of our users, a workflow that is a loop that like every certain amount of time runs a task to check for some condition in the world, and then if it is out of line, it runs some compensation thing. So it's like a loop that just kind of runs forever, right?
Yeah, okay.
There's other ways to do it. Is that the best way to do it? Not really, right? But that's not really a business thing. That's literally like it's checking the validity of a token, which is not a business process. That's a technical process, right?
That's yeah. And you may nothing's going to produce an event when the token expires, and so you poll.
Correct. That's very, very much durable. Very much a use case that you could do with durable execution, or you could have a cron job that does that, and well, we do have a cron run workflow capability, which probably would be a better way to do it than have a loop running forever. But that works, and we're making the server support that a little bit better. But on the other end of the extreme, we've got someone who's building a work order management system where there's one workflow for managing a work order, right? That's very different than a workflow that checks the validity of a token. And philosophically, on one extreme, I'm just running a bunch of tasks on different computers, right? Another one is, hey, this workflow models a very core business process. And there's steps, including human in the loop steps. There's, exception handling and error handling. We call exception handling something in the business going wrong, like a credit card being out of funds. Error handling is something like 500 or APIs down, right? And we handle those errors differently.
Okay, an exception is a business process exception. An error is something broke.
Something broke,
a computer broke, basically.
Correct. Or you had a bug in your workflow, like you passed it into when you need a string or something like that. Okay, actually, that would work, but you pass a string when you need an int, right?
There you go. It may not work, right?
Yeah.
Or it would not work I'll throw something out. Tell me if this resonates or if you've thought this way. In my mind, business software and business workflow engines get at the absolute heart of business software because they take a process that a business does and they try to encode it literally. And I'll put that a different way, a somewhat more philosophical way. If you could imagine a pre-automation business, some company in 1950, or plenty of businesses don't do a lot with computers, but just any company doing stuff. You got an office full of people, and they pass information around. They have forms, they have memos, there's files, and they do stuff. They interact with customers and with each other, and the business process is mental. It's stuff that they learn and do in their mind, and you have to learn, but you get good at it, and you do it, and there can be exceptions like, this person didn't fill out that part of the form, but it's okay, I know what they mean, or they didn't fill this out, but they've had this, and I can kind of guess, and all the kind of messiness of doing stuff as a person, or using language is the same way. There's all kinds of stuff that's vague and unclear and implied, but we get by. So business is this mental world. And then when we take that and this has been going on at a rapid pace in the last 30 years, you take those processes and you try to turn them into machine instructions, basically, in whatever language you want. That's really hard. It's like a kind of alchemy. We as developers, we do this magic where we take these business processes and turn them into machine instructions or formal language, expressions in a formal language. And doing this with, so I'll say it again, that's super difficult. It's not everybody can do that. And the people who gain the ability to do that, well, we call them software developers in the world of enterprise software. And we use these extremely open-ended, general-purpose Turing-complete programming languages for that. Then you have the early attempts like BPM of doing it in XML, and you pretty much just end up reinventing a Turing-complete language that's just really ugly to look at. And
also single point of failure, slow.
Well, of course, there were architectural problems with the engines that
the 1990s workflow, very different than like the Camunda V8 and Little Horse and Temporal.
And we're doing the best we could with the tools that we had. Maybe not last question, but among my last questions, that workflow language.
Mhm.
You called, I forget what you called what Little Horse calls it, but that way you express the Java DSL.
Yeah.
Are you successful in keeping that? Do you think you can be successful in keeping that from just becoming another programming language? Can you do it?
We're joking about a project called Hoof internally. There's a lot of we're about to release a product called Saddle, and we're working on renaming something Pony ID.
I like this kind of Western theme. This is
our
good.
serverless cloud is going to be called Pony Express. So we're thinking about Hoof as a language that there's a compiler that takes that language and compiles it directly and runs it on the Little Horse server, just like Java is compiled by Java C and then run on the JVM, right? It'd be exactly the same thing. So why are we trying to keep it? Well, because the Python, Java, C Sharp, and Go DSLs are working just fine, and people have they've given us feedback. We've been able to, most of the feedback we've got, almost all of the feedback we've gotten is minor bells and whistles, not an architectural fundamental complaint. So we just haven't built, the actual, programming language itself. But the key thing you said is hit the nail on the hammer, which is, there's this kind of emergent business process, and there's a lot of manual steps, and there's data that is moving, data that's getting lost, especially when there's not automation or there's stuff getting thrown into legacy systems or even modern third-party SaaS systems that don't have great APIs. There's data that you're not capturing and unable to put into your analytics engine and such. So to go map that process into something technical is very valuable for many reasons, because you can, do things faster, you can get more analytics out of it, you can automate things. But that process is difficult because there's a lot of asynchronous passing things between different nodes, where a node is a person, it could be now an agent, it could be an external API, like you throw something to Manhattan Associates to do your order processing, like you call it Active Omni, right? Then some days later, they'll throw back an event to you to say that this order has been shipped, right? Then you go take that information and you throw it at a system called XCC, which will calculate some payment information, and then you send it over to Oris, and then later on Oris tells you that the payment is done. So you're taking data and you're chucking it somewhere, waiting for it to come back, right? And if you try to write this process in normal Java, you're going to end up with a bunch of Spring Boot endpoints, either on one server or on a different server, that accept a webhook from something or read an event from somewhere, do something, and then throw the event somewhere else. So you end up with little disjoint pieces of this logic spread over a bunch of different endpoints. And those endpoints are often now spread over a bunch of different microservices. There's nothing that allows you to durably write something that says, okay, now what I'm going to do, I'm going to initiate the order process in Active Omni, and I'm going to wait for Active Omni to send something back. If it doesn't send something back in a certain amount of time, I'm going to go ask the customer, hey, do you still want me to wait because perhaps the item is out of stock, or do you want to cancel your order, right? And then we wait, and depending on that, then we'll go to Kobe, calculate the price given loyalty points and such, then send it to Oris for payments and such, and all of that lives in one place, and it is orchestrated by one thing, the server. And the work actually doesn't run on the server is what we call Little Horse, and it's an internal word. I guess we might make it. There's many things called the server, but
naming things is hard. Pinot has servers in it as well. Like, server, I see.
Name it. But
in contrast to.
Sorry, all that's orchestrated by the workflow orchestrator in Little Horse, and you get to write code that corrals that process and handles things, takes care of retries for you, takes care of making it really easy to handle exceptions, and it runs in a non-blocking manner across many different computers. So you could have complex processing that requires a GPU as one of the tasks, and the task would be sent to a worker on that physical infrastructure. And you could have just plain old just fetch something from a database or call this API running on other task workers, other places.
Got it. This brings us back to your original insight, which was, you could debug operating systems projects in school with GDB and VS Code and see it all. And in a modern, just somewhat complex not hello world enterprise environment, there's all those services and you're getting, so yeah, maybe it does become just a programming language, but you've got this one view over the whole thing.
Exactly.
And it is. I mean, you started by saying it was Turing complete, but it's a simplified language that, yeah.
Our website used to say a distributed operating system for the enterprise.
Okay.
Distributed as in an operating system, basically you tell it to run a program and it will assign that program to run on certain cores, right? And
yes.
With a single operating system program, you can debug it and you can see exactly what's going on. The idea of calling Little Horse a distributed operating system, which is very much a marketing term, is that, well, this program runs on Little Horse, but it runs on many different servers that are distributed. And in fact, certain steps of it can involve human input as well.
They could have nothing to do with Little Horse resources. They could be Salesforce. It could be, Pinterest or whatever.
Yes.
Yeah.
Exactly
Okay.
that. If it's something you can interact with through code, you can have it as a task in Little Horse.
There you go. To close, you're a startup, but you've talked about customers. What kind of impact is this having? What are you seeing this unlock? You're still building it. There's a vision I sense that you haven't achieved yet.
Correct.
But you've got product. And what change is it bringing about in the world?
I think, the goal is, if I ask anyone on the street, well, not on the street, if I go to Current and I ask anyone, what do you think of when you think of relational database? They'll say Postgres, right? And then I ask, what do you think of when you think of cloud storage? You'll almost always get S3. You might get like a GCS or something, right?
Sure.
If I ask,
and somebody's database, somebody might say Oracle, and you'll be like, nerd.
Well, I really.
But those are the associations we have.
Exactly. Yeah. And I think I ask you, what do you think of it for cache, right? Everyone thinks Redis, right?
Yeah.
Or for a search index, you'll think of Lucene or Elasticsearch. Now,
yeah.
I want to be able to go to Current and say, well, what do you think of when you think of distributed app management? Or what do you think of as a solution to writing applications in a distributed environment? I want people to say Little Horse, right? People would say, what do you mean managing distributed applications? They just accept that it's so hard to do this. They don't really think about the fact that there might be a better way to do it. And I want Little Horse to become so mainstream that the open source project is used ubiquitously.
My guest today has been Colt McNealy. Colt, thanks for being a part of the Confluent Developer Podcast.
Thanks, Tim.